Before we used the pipette, we rinsed it 3 times each in water and solution, which was, in this instance, an unknown solution. I went first. To use the pipette, I squeezed the air out of the blue bulb and submerged the end in our solution. When I released the pressure on the bulb, the pipette drew up a quantity of solution. The curved shape at the surface of the aqueous solution is called a meniscus. Solutions with water form a meniscus in the pipette because water is polar or composed of positive and negative ions, known as cations and anions, respectively. Likewise, the glass of the pipette is also polar. The glass's ions attract the water's ions of opposing charges, pulling them slightly up the walls of the pipette and creating the meniscus. In order to properly determine the volume of the solution, it was necessary for us to read at eye level at the very bottom of the meniscus. The volume that I drew was 6.35 milliliters. After I delivered a quantity to our beaker, the volume in the pipette read 8.05 milliliters. By subtracting the initial volume from the final volume, we determined that the amount of solution delivered to the beaker was 1.70 milliliters. Then it was Sydney's turn to use the pipette. She determined that the initial volume in her trial was 5.55 milliliters. After delivering to the reaction vessel, her final volume was 6.65 milliliters. Therefore, the amount delivered was 1.10 milliliters. Jay then repeated the process. His initial volume was 5.70 milliliters. And his final volume was 7.60 milliliters, so the amount delivered was 1.90 milliliters. Finally, Michelle tried her hand at the pipette. She drew 6.51 milliliters of solution, delivered an amount to the beaker, and read a level of 7.60 milliliters. The quantity she delivered was 1.09 milliliters. We recorded all of our results and calculations in our notebooks for later reference.